All right, so for problem number 11, it says find the absolute maxima and minima for f of x equals 5x to the fourth minus 10x squared plus 8 over the interval -3 to +3. So the first thing that you want to do is find your critical values. And the way that you find the critical values is by setting the derivative of this function, the first derivative, equal to 0 and solve for x. So because our function, by the way, since our function is a polynomial function and its domain is all real numbers, then the only case that you have to consider is when f prime of x is equal to 0. When you look at the first derivative is also going to be a polynomial function. So we don't have to worry about values of x that are not in the domain of the first derivative. Okay, so let's just find this first derivative since I talked so much about it. Well, the first derivative is going to be 20x to the third power minus 20x to the first power plus 0. So what you'll do is take the first derivative, 20x cubed minus 20x, set this equal to 0, and now solve for x. Between 20x cubed and 20x, you can factor out 20x. And this will leave you with x squared minus 1 is equal to 0. Now, you can continue to factor this because when you look at x squared minus 1, it's a difference of two perfect squares, which is x plus 1, x minus 1. So you have 20x times x plus 1 times x minus 1 is equal to 0. And you can solve for x. If you solve for x, the three values you'll get is x equals 0, x equals a -1, and x equals a +1. So these are your critical values. Now look at the interval of interest. The interval of interest is from -3 to +3. Are these critical values inside of that interval? Yes, they are. So we don't reject any of the critical values. The only time you reject those critical values if any one of those values lies outside of your interval. So like, for example, instead of having an x equals 1, if we had x equals 5, hypothetically speaking, then I would have rejected it because we're only looking at this from -3 to +3. All right, so now we just finished the calculus part. Now we have to do the algebra or arithmetic part. The arithmetic part basically says you have to do the evaluations. In particular, you're evaluating the function at the critical values and the endpoints. So I have to do f of -3, f of +3, f of 0, f of -1, and f of +1. So I'm going to start with the bottom three because those three might look a little easier to do by hand. The other two, I might have to do a little bit more work. So if I want to evaluate f of 0, I plug 0 into the into our original function. For this one, you're just going to get 8 since the first two numbers will be 0. If I plug in -1, you get 5 times -1 to the fourth minus 10 to the -1 squared plus 8. Well, -1 to the fourth and -1 squared, since -1 is being raised to an even power, they're going to be positive values. So this first value should just be 5. Here we're going to have -10 plus 8. So you can do 5 plus 8 first. 5 plus 8 is 13. 13 minus 10 will give us a 3. All right, if I want to do f of 1, this is going to be 5 times 1 to the fourth minus 10 times 1 squared plus 8. But we'll get the same results as the previous when I plugged in -1, right? These values are going to be 5 and -10 plus 8. So 5 plus 8 again is 13. 13 minus 10 is 3. All right, now I just got to plug in the two endpoints, -3 and 3. And again, this you might have to just be careful with. So let's see what happens. If I do -3, this will be 5 times -3 to the fourth power minus 10 times -3 to the second power plus 8. Well, negative 3 to the second power, I'll do the middle one first. Negative 3 to the second power is 9. And if I do 9 times negative 10, this becomes negative 90. So far I'll have a negative 90 plus 8. Now, negative 3 to the fourth power is positive 81. So just quickly here, 81 times 5 is 405. All right, so you will have 405. You can add an 8 first. That will give you 413. And then you can do 413 minus 90. So if you do 413 minus 90, that would be 323, I believe. Yeah, because bring 3 minus 0 is 3. Then you make this 11. So, yep, 323. So we get 323. Now, because f of 3 is going to, because this function involves even powers, when I evaluate f of 3, we should get the same thing. So this was also 323. And now you can compare. The maximum value is 323. So you have an absolute max of 323 at two values of x. Those values were negative 3 and positive 3. You have minimum values of 3. So you say absolute min of 3 at x equals negative 1 and x equals positive 1. And that will be it. That's your solution to problem number 11.